We're going to take a look at some expressions in example 2 to be evaluated. You notice these expressions involve radicals or fractional exponents. Let's take a look at part A. We want to evaluate 64 to the 1/2 power. Well, if you're not sure how to do that at this point, we can explore using our calculator. If you take out your calculator, we're going to type 64, and if you want to type an exponent, you have to use the caret button. So what that means is, if you look over here on the right-hand side by the operation buttons, plus, minus, times, divided by, right above those buttons, you see the caret button. Looks like an upside-down V. So if we want to type 64 to the 1/2 power, we've typed 64. Now we'll press the caret button. Now we'll type in 1/2. If your calculator doesn't behave the same way when you press the caret button, that means you have the old operating system for a calculator. I can update that for you here in school, or I can show you how to update it at home if that's what you want to do. Well, now we've typed our expression, we'll simply press enter, and you see that 64 to the 1/2 power is 8. Okay, now moving on to part B. We have the square root of 64. Well, this one we can do mentally. We know that the square root of 64 is 8. So what you notice now is that 64 to the 1/2 power is equal to the square root of 64. Raising any number to the 1/2 power, it's doing the same thing as taking the square root of that number. Now let's take a look at part C. Once again, we can explore this using our calculator. We want to find 81 raised to the 1/4 power. So we'll press 81 caret and now 1/4. You see, our value is 3. So 81 to the 1/4 power is 3. And now let's take a look at part D. We want to type the 4th root of 81. Well, we can type the 4th root on our calculator, but it's a little more complicated than it needs to be. So rather than going to our calculator to type the 4th root, let's keep in mind that 81 to the 1/4 power is equivalent to the 4th root of 81. Fractional exponents really tell us the same thing as radicals and roots. So we know that the 4th root of 81 is going to be 3. So that's our introduction to fractional exponents. Let's go to part E. In part E, we have a product underneath the radical. So let's get started simply by writing this as the product of two radicals. We can call this the square root of 25 times the square root of x squared. The square root of 25 is 5, and the square root of x squared is technically the absolute value of x. I'll explain why in class. And if you missed class and you want to know why the square root of x squared is x, come on in and talk to me at school. You can come in during seminar or before or after school. I'd love to show you why this is true. This is it. Now I'm afraid that when you check answers in textbooks, oftentimes you're going to see this same expression simplified to be 5x. We're going to be a little more technical, and we're going to recognize that the square root of x squared is in fact the absolute value of x. Now moving on to part F. We're going to take 121 times y to the 10th power underneath the radical and split that up into two radicals. The square root of 121 times the square root of y to the 10th power. So let's look at it like this. The square root of 121 is 11. And now we need to figure out what the square root of y to the 10th power is. So we could look at this a couple different ways. Y to what power squared is going to equal y to the 11th power, or y to the 10th power. Oh, this is getting cramped. I'm sorry. Make this look a little neater. So y to what power squared is going to equal y to the 10th power? Well, you remember when you raise one power to another, our shortcut is to multiply the exponents. 2 times 5 is 10. So y to the 5th power squared is y to the 10th power. So now we can conclude then that the square root of y to the 10th power is y to the 5th power. And there you have it. That sums it up for example 2. I hope this video was helpful. As always, thank you for watching, and if you have questions, Bring them into class or seminar or before or after school. Good luck when working on your practice problems.